Hi, today you are going to learn how to use the Wireshark for capturing and analyzing network packets. First, we are going to see how to download Wireshark, if I may say. So first, we will open our web browser and go to the Wireshark website. So we'll type wireshark.org. And here now we are on the Wireshark page. So here we have the icons. Here is the icon for downloading. We just click on the download icon, and here we have the list of installation packages. So as for my machine, it's using Windows Installer 64-bit. It's a 64-bit machine, and that's the one that I'm gonna use. If you're using a 32-bit, you can select 32-bit, or maybe if you are using a Mac operating system, you can choose that one. So as for me, then I will download the Windows Installer application. And then I click. I will click on save, but in this case I already downloaded it here, so I will skip this step. So you can continue to click on save and then wait for the download to finish. And then after downloading the application, you'll go to the location where you have downloaded your Wireshark application into. In this case, it's in the downloads folder. So you'll open the Wireshark application and follow the steps. Yes, click on install anyway. As for privileges, you'll select the Wireshark desktop icon so that it can be able to show on your desktop, and continue. Click next. And then we click next there to finish the installation. And then now we are done installing our packet sniffer application. So having installed our Wireshark application, now we will dive into capturing our packets. So we'll open our Wireshark application. So as you see here, we have this interfaces here. These are the interfaces that we are going to use to capture our packet. So it depends on the interface that you are connecting to the network or to the internet with. So in this case, we are using, or my PC is using the Wi-Fi, so that's why you can see the signal here signaling that the network is busy. So there are different ways to capture, or there are different things or conditions to note. So here, sometimes when capturing, you may need to apply a filter before capturing, or else you apply a filter after capturing. So when talking about a filter, I talk about the protocols that you may need to capture specific packets for. So sometimes you may need to capture packets for file transfer protocol or DNS, or probably HTTP protocol or TCP. So it depends. So in this case, we'll just capture, in our case, we'll just capture all the packets. We won't be specifying the type of filter that we may need, and go to our capture options. So to access the capture options, you'll just click this icon here. So here again we have the very same adapters here, of which again still you can specify the type of packet, but then before doing that, it can happen in two ways, of which you can specify the type of protocol prior before you capture, or else you can just specify, like, can you just capture every kind of protocol, and then after that you can specify the type of protocol after capturing those packets, if I may say. So now here I won't be specifying any kind of or any type of protocol, just for the sake of capturing enough data so that we are able to work on it. So it won't be just one capture. I'll do at least a couple of captures. So let's go to it now. So we'll click on this adapter again, and then after clicking that, we'll just click on start. So again, it's up to you how many packets probably you may want to capture. Otherwise, you can capture as much packets as you want. So in this case, I'll just stop our packets capturing using this button. You just click on the stop capturing packets button here to stop the process of capturing. So now we have we've got all these packets here. So what you must note here is that every row, every field is a packet on its own. Every row of field is a packet, as you see here. So sometimes the packet may have data, sometimes it may not. So it depends on the request that was made by that specific host. What was the requirement? So that's why, and also depending on the protocol, just like ARP, just to resolve addresses only, so definitely there won't be any much data. Okay, so now we'll save what we've just captured here. So saving the captured packets, we'll just save them. Normally we will save in a format that's called pcap, which is packet capture format. So we'll just go to file, click on save as, and then you can go to we can file. Just create a new file on desktop where we will be able to access it. It's like here we have this file here, so I will just save first. Maybe let's just save it as pcap. Just save this file. And then extension that you want, of which is pcap, is packet capture. So we'll be able to open our file if it's in this format, and still we'll be able to access the very same packets. So yeah, so we'll just save it in this format, in this folder. So yes, let's just overwrite it. Yes. And again, you can continue, and again you can continue and capture more packets. Again, we'll do the very same thing that you did before, and we'll capture another batch of packets. And once you've captured enough, again you come here and click on stop, and then you can save these packets. And I'll save this file too. Okay, you can use pcap. It's easy to use pcap. And now let's unread the last packet. Let's capture the last packet. Okay. And we save it. Okay. Okay. So now we are done with capturing our packets. So now what's next? May I just specify what's going on, especially within this pane here? So this packet capturing pane. So first we have this number here. This is just a sequence number, of which is it only states the number of the packets. If it was number 1, it was the first packet future status of the packets. As you see, there is numbers such as sequential, they are increasing by 1, and then it's just the time to capture the packet, which is nothing much, and then we have the most important part is our source address. This is our source address. So as you see here, our source addresses are different. Sometimes you see some kind of a name convention and 6 bits, which means this is a MAC address specifying a specific type of brand, of which definitely the 6 bits of that MAC address will specify the type of device. So this was device, which means it operates at layer 2. So that's why it only shows this address, and then likewise with these ones, they operate. So coming here to actually our address working hand in hand with our destination address. So every packet has a source address and a destination address, and then it has a protocol of which it operates with, and then every packet also has a length, which is the size of the bits that will be sent over the network, and also its info. Within this info, sometimes it depends. Sometimes the packets will have a specific port number, which means this first port number is the one for the sending device, and also this port number is for the receiving. Actually, the receiving or the destination host, if I may say. So that's all about this capturing pane. So next we will see how to capture. Actually, in capture, we'll see how to analyze our packets that we've just captured. Capturing the packets that we intend to analyze. So our next step now is to get into each of the packets, of which is the bundle of packets that we may need to analyze, if I may say. So here we have this folder that we use to save our packets. So we'll just open, and in this case we'll start with this one here, of which we just saved packets specifically for TCP/IP, which we just applied a filter that will help us to filter only the TCP protocols that are associated with the TCP, only packets that are associated with the TCP protocol. So in this case, this is what we got. So first, before going into analyze each and every packet, first I'll just elaborate on this packet filtering pane. So first, here we have a sequence number, of which is the number that is not that unique, but it's unique in a way that is the order in which the packets were captured from the internet or from the network. And also we have the source address for the sending host or computer, and the destination address. We have the protocol, that's the protocol of which the packets are using to communicate, of which the source and destination computers are using to communicate and send the packets. So there's the protocol that they're using. And we have the length, of which is the size of the packet, of which is in bytes. And then we have these numbers. These numbers, we can see that we have the first one, and we have an arrow pointing to the next one, which means this is the port number of the sending computer, of which means it's sending. Of which means the next one is the port number of the destination computer or receiving computer. And then we can see some synchronizations and acknowledgements. Actually, these keywords are for synchronization, and also the acknowledgement of actually they are for making sure that transmission, therefore reporting that transmission was successful or not. So there are some flags. So we'll be using actually every sending computer or receiving computer. They use this the synchronization and also acknowledgement, especially for TCP. There has to be an acknowledgement number to show that indeed especially when it's doing the handshake procedure. So that will help to notify the other computers, oh, indeed the sending was a success. So we'll continue into the frame. So the frame, likewise, it just shows the number of which the frame will show whenever you click on every packet changes. So every packet has its own frame, and Ethernet protocol, and internet and IP version 4 protocol, and also TCP protocol. So every frame has that. So in this case, on the frame, you can see the size of the data that is being transferred, and we see the encapsulation, which is Ethernet 1, of which is the protocol or the medium on which the packets are traveling through. And we have the time here. And also what's important here. Okay, now let's go to our next protocol here. And we have the Ethernet 2 protocol, which specifically defines the sending, especially it specifically defines the MAC addresses of the sending devices. So the first 6 bits, we can see just here from the first 6 bits that it's an Apple device, which is the source, and the destination device is a Raspberry. And these are the first 6 bits which defines that manufacturer or that brand. So likewise is the same that we have here. And then next, so here we have the header, of which is IP version 4, of which the header length is 20 bytes. And also, what do we have that's interesting here? Oh, the flags. Oh yeah, the flags. Sometimes you'll see multiple flags here, of which they are just some kind of PC data showing the success of the transmission also. Likewise, TCP protocol, which is the protocol that the packet is using to send or to travel over the medium. Source and destination IP address. And again, here we come. These are the ports from the control protocol. You can see again the port number for the source, of which is the sending computer sending the request, and the saving computer, which is saving the request, of which the destination port. And you can see the sequence number and the acknowledgement, which means this was a success, because if it's 1, this means it acknowledges that the packet was sent successfully. If it was 0, that will mean that it wasn't successful. So that's how we'll see, or we'll know success. Likewise, as we stated earlier on, that these are the acknowledgements of which they work hand in hand with the flags to signify the success of the transfer of that whatsoever packet. So now we are done with this. Now we are going to analyze each and every. Actually, now we are going to specifically analyze a packet and then see what is really inside, because the main importance of capturing the packet is to intercept it, and also to find what is inside after intercepting it, what is inside the packet, of which it will help us to know what kind of procedures we should implement to protect that kind of information, and also to know where is it coming from which device is it coming from, where it's not protected. So we just click on any packet here, and you can see as you click on that packet, you'll see the data here. There's some data, of which the line is just like here is 15, and there's the data here, which means there's something in that packet. So if you right click and follow that packet, and then go to TCP stream, oh boom, and then you see in this case we get exactly the real content of the message, which means that this message was not encrypted. It was just the sending device actually doesn't use any encryption at all. It doesn't even use the encoding, of which is normally we use the 64-bit encoding, of which is not an encryption standard, but it's just an encoding standard, of which it just translates the data into another form that can be easily transferred over the medium. So it doesn't mean that maybe it's an encryption. So, however, in this case, it wasn't even encrypted, it was just sent as it is. That's why you can, whenever you intercept it, you just get the text as it is. So if probably we wouldn't, if maybe this data was not that clear, we would have saved it using the raw format, and then later try to find out what kind of real data this is by saving the file, and then trying multiple types of files, which could be probably JPEG, it could be a text, it could be an HTML file. So we'll try all those files by changing to different version and trying to open that file in that case, or else trying to change the encoding using encoding softwares, which is possible also. So let's go to let's open another packet. So now let's try an FTP packet. and see what is inside. Still, we can just take any packet here, but with these packets, we were lucky that the source that we sourced it from is like the data was not encrypted at all, because if we see from the information here, you can see that you can just get the real username and password directly. They are not encrypted. There is no whatsoever, which means they are not using any kind of encryption at all, which means this network is not secured at all, because you can see everything that is being sent over the internet. You can read anything without any problem. So let's try to follow its packets. Likewise, so when I follow this packet, you can see that there are a couple of items inside, which means indeed there was nothing kind of encryption that was used, or either some kind of encoding. This was just plain text sent over the network, which means they still need to enforce some kind of rules that should protect this kind of information. So yeah, this is what we got. Okay, let's try another packet, probably DNS. In this case here, we don't have any DNS, so we have already saved DNS packets here. Let's open this one here. Okay, wow. Oh, there are a lot of packets here. So we can just choose any DNS packet here. Which one can we use? Yeah, can we just select this one and right click on it, and then we follow the stream. Oh, it uses the UDP stream. Okay. Again, here the data wasn't encrypted in a way. After all, it's just an DNS information. So nothing much will do with this information. Probably that's why it wasn't encrypted. But if let's say if this was encoded, probably, or maybe encrypted, so that's when we will go to this text box here for this option. So we'll select just row. We're selecting row, we'll save it. We'll just save a file, probably just say file one. File one wouldn't state the kind of a file, because really we don't know what kind of a file is it. So we'll just save it as row. Then once we have saved it, that's when we'll then try to rename it with any kind of extension, because we wouldn't have any idea what kind of data that is inside that packet. So that's why we will try multiple extensions, or else we can use online applications that will try to assemble the packet in different multiple ways until maybe it finds a certain pattern, and then to rename that pattern with that kind of extension. So that's how we will also find the kind of information that's inside the packet. So basically, you may say that Wireshark will just help us to intercept those packets. It could be for a bad thing, or it could be for a good thing. So in our case, it's a matter of enforcing security, and it's a matter of improving the security of our applications, of which they are sending information over our network at any instance. Yeah, thank you for watching.